Hi, I'm Miss Hall, and this is Lesson 24, Solving Quadratic Inequalities Algebraically. Okay, so we've had experience solving quadratic equations. We have many ways to do that with graphing, by completing the square, by factoring the quadratic formula, and now we're going to be solving quadratic inequalities. So inequalities in equal, there's not going to be an equal sign. There will be an inequality symbol, right? Less than, equal to, greater than, equal to. And we'll get right to it. So we have a quadratic inequality to solve algebraically. I break these down into 3 steps. My first step is to identify the boundary points. Right? We're not equal to values, but we're between some values when we solve an inequality. So to establish the boundary points, we're going to change the inequality symbol to an equal sign. So x squared minus 3x minus 4 equals 0. It's going to give us the boundary points when this equation equals 0. This is a factorable quadratic, so I'll choose to factor it. X minus 4, x plus 1. Yep. And so my boundary points are positive 4 and negative 1. Step number 2. I'm going to plot the boundary points on a number line. Here's my number line. It needs to include up to positive 4 and down to negative 1. So I'll go from positive 5 to negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to identify those boundary points first. That is positive 4 and negative 1. Now I got to figure out if I shade in those points or if I leave them empty. And the rule, if you've forgotten, is if you have is less than or is greater than, you leave the points empty. And if you have is less than or equal to or is greater than or equal to, you fill in the point because it can be equal to that point, right? These are the points 4 and negative 1 where the x value would equal 0, and this inequality says it is less than 0. So we do not fill those in, but we've drawn our number line. Last step, we are going to test intervals. What I mean by that is that either, I think I can do this and erase it, these values make the inequality true, the values between those 2 boundary points, or the values on the outside of those boundary points make the inequality true. So we need to figure out which it is, in between the points or on the outside. And to do that, we pick a point and we test it. And I always like to pick an easy point, and for me that is 0. So I'm going to say, can x equal 0? Does that make the inequality true? To figure that out, I go back to my original inequality and I plug in an x value of 0. So is 0 squared minus 3 times 0 minus 4 less than 0? And I chose 0 because 0 squared minus 3 times 0, that's all 0. So I'm left with negative 4 less than 0. Is negative 4 less than 0? Yes. So that means that point is included in the interval that makes it true, which means I can shade between my boundary points. These are the x values that make the inequality true. If you didn't believe it or wanted to test it further, you could test points on the outside, like you could test x is being equal to positive 5 and make sure that made the inequality not true. But once I've established that, got it, so I can rewrite this now as an inequality that x values less than 4 and greater than negative 1 make the inequality true. So there's my answer. Negative 1 is less than x is less than 4. And we're going to do one more, the same 3 steps. First, we're going to identify the boundary points by setting the inequality equal to 0. and solving for when this inequality equals 0. This is again a factorable quadratic. So x plus 8, right? Plus 8 minus 4. So the boundary points here are -8 and +4. Step number 2, plot these points on a number line. Here's 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, -5. 1, 2, 3, 4, 5, -10. Points are 4 and -8, 6, 7, 8. Now I'm going to check the inequality. This inequality is greater than or equal to, so the boundary points are included in the solution, which means I shade them in. Now I'm going to test a point. I love 0, so I'm going to test 0. If 0 is true, I'll know to shade in everywhere between the points, and if 0 is not true, I'll shade the outside parts. So we have 0 squared plus 4 times 0 minus 32, is that greater than or equal to 0? Is -32 greater than or equal to 0? Just put a question mark there. So I'm looking, is -32 greater than or equal to 0? No, this is not true. 0 is not part of the solution set here, so I do not shade the part that includes 0, which means I shade the outside parts. And I shade it and include an arrow, so it goes on forever towards infinity and on forever towards -infinity. Again, if you wanted to test and make sure, you could try a number greater than 4, like 100 or 1,000,000 or 5, and make sure that was true. And you could try a value less than -8, -10, -100, -1,000, and make sure that made it true. So now let's practice writing this compound inequality. So here we have x is less than or equal to -8, right? It maintains that is equal to property, or x is greater than or equal to 4. So when it's on the outside, we need this or in the middle of our two inequalities. X is less than or equal to -8, or x is greater than or equal to 4. Great, let's go through the 3 steps. First, identify the boundary points by setting the inequality to an equal sign. X squared plus 10x plus 9 equals 0. This factors to x plus 9 times x plus 1. My boundary points therefore are -9 and -1. Step 2, plot the points on a number line. Put 0 over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And circle -1 and -9. Check. Do I include them? Do I shade them in? No, because the inequality isn't equal to. The inequality sign is less than. Third step, test. I am going to test 0 here. And so if 0 is true, I'll know the outsides are true. And if 0 is false, I'll know the inside is true. So let's see, 0 squared plus 10 times 0 plus 9 is less than 0. Put a question mark. Is that true? So is 9 less than 0? No, that is not true. 0 is not part of the solution set. Therefore, I'm going to shade everything in between -9 and -1. And I can write this compound inequality as -9 is less than x is less than -1.